Hi guys, hope you guys are doing well. You guys have an exam tomorrow. If you are here to get the participation points for my class for missing Zoom or whatever this week, just put your name in the chat so I know you're here and I can give you credit. Otherwise, let's get started. All right, so you are on your exam tomorrow. You're going to have questions that ask you to evaluate, questions that ask you to solve. You'll have to identify different points of absolute value. So let's get started. Okay. With these, it's always best to work the absolute value first. So this negative out here, he's going to stay out there no matter what. And then when we take the absolute value of, actually I'll leave it here, 1 minus 9 is negative 8 on the inside. So we're going to leave that like there. And plus, and then we have the absolute value of negative 1 there. Negative 5 plus 4 is negative 1. So when we're here, the absolute value of 8 is 8. This negative has to stay. Okay? This one's going away because we're taking the absolute value, but this one stays. And then this one right here, the absolute value of 1 is 1, positive 1, and it's a positive on the outside. So this is going to equal negative 7. All right, there's the first part. Let's do B. All right, absolute value first. This negative's on the outside. 6 plus 9 is 15. We have the absolute value of 15 plus the absolute value of negative 3 is just 3. Hi, Everett. Thank you. So we have a minus 15 plus 3 is equal to a negative 12. Okay. So again, if you're here because you missed a Zoom or something, let me know. I'll let your teachers know that you were here. And that way, maybe, I know in my class, I'll let you guys make up the points for that. And, we can go from there. All right, so there's the first one. First two, evaluating. Let's solve. Okay, when you solve absolute value, you need to make sure that the absolute value is by itself. And so for this one, look at, there's nothing on the outside of this, we're good. This one, there's something underneath here. This one, there's a negative here. This guy's got stuff over here. So you need to make sure that there's nothing on the outside of the absolute values before you start. Once you have the absolute value by itself, when it's isolated, then you set up your two equations. So for your two equations, remember you go for the positive and the negative. We have x plus 9 equals 14. There's the first one. And x plus 9 equals negative 14. And then solve your equations like you would normally solve equations. So you subtract 9, okay? You get x is equal to 5. And then you subtract 9 here, okay? And x is equal to negative 23. Okay. Good thing with absolute value, you can always check your work. So you could take these numbers, plug them in here, and make sure that they worked. So when you're doing your exam tomorrow, when you're working on this, take a couple minutes. We're going to give you guys 75 minutes to take your exam. Take an extra minute and plug it in and make sure that it works. When I plug in 5, does that give me 5 plus 9 is 14? The absolute value of 14 is 14? Yeah, that works. So it's worth it to take the time so you get it right. Okay? Let's do B. Absolute value is not by itself first. You have to deal with that 5. Okay, and so this is like something over 5. So to get rid of that, we're going to multiply both sides by 5 because that's going to get rid of that. And we get 2x plus 2, the absolute value of 2x plus 2 equals 50. And now that we're here, we can set up our two equations. 2x plus 2 equals 50. 2x plus 2 equals negative 50. And solve. So subtract 2, and let me grab a piece of paper here so you guys can see it, so we're not wasting space here. Okay, so I've got 2x is equal to 48. Divide both sides by 2. X is equal to 24. Okay, same with this one. I'm going to subtract 2 to both sides. I get 2x is equal to negative 52. Divide both sides by 2. X is equal to negative 26. All right. So those are your two answers, and your solutions will look like that. Okay, so that's that one. That's B. All right, C. Something that we kind of saw a few guys doing, especially on the quizzes and in other things. You guys wanted to distribute this, okay? We don't want you to distribute. Distributing's no good, okay? Don't do that. It works sometimes, but doesn't work others. And it definitely doesn't work in this situation. You have to deal with that first. So what number is here in front of this negative? It's kind of, or in back of it, it's kind of like a -1, right? That's a -1. Mr. Nakauchi calls those ghost ones. It's one of my favorite things I've taken from Mr. Nakauchi. So to get rid of this, we're going to multiply both sides by a -1. Okay, and that's going to get rid of that for me. So we have the absolute value of 10 plus 5x equals positive 45. Okay. This kind of problem is going to come back to haunt you. Make sure you deal with this negative first. You cannot distribute this. If I distribute that, I get -10 minus 5x equals -45. And we know that you're not going to get the absolute value of something is going to be negative. So it completely changes the problem when you don't deal with this first. Make sure you deal with that first. Okay, I'm here. Get your two equations. There's nothing else. So I have 10 plus 5x equals 45. 10 plus 5x equals -45. And just solve your equation. Subtract 10. 5x equals 35. And then x equals 7. And I divide both sides by 35. And then x equals 7. Subtract 10 there. 5x equals -55. Divide both sides by 5. X equals -11. So those are your two solutions. Okay, so a problem like this has two solutions. All right, let's do this last one. I'm going to put it up here for you guys to see because I ran out of space. So we have 3 times the absolute value of -7x plus 6 equals 90. Okay, when you're faced with multiple things to do, you want to deal with the addition and the subtraction first. Okay, so do anything where you can add or subtract first. So in this case, I'm going to subtract 6. And then I'm going to get 3 times the absolute value of -7x equals 84. Now deal with this. Don't distribute it. Okay, in this case, it will probably work out for you. Don't get into the habit of doing that. Divide it out by 3. Okay, and you get -7x, the absolute value of -7x, is equal to, and then here's where, again, if it takes you longer to do the math, then take the extra few seconds it takes to put out your math and do it correctly so that you don't make silly mistakes guessing. Okay, that's what you don't want to do. So we're going to get the absolute value of -7x equals equals 28. Now that it's by itself, set up your two equations. We have -7x equals 28. -7x equals -28. Divide both sides by -7. X equals -4. Divide both sides by -7. X equals 4. Okay, so you have your two answers for that. And then your solution would be -4 and 4. Okay, those are your solutions. Okay, so those are solving absolute value equations. All right, moving on. All right, true, false. F of x is equal to the absolute value of x minus 2 minus 3. Okay. On your exam, they're going to ask you, kind of like when you had your quiz, when you guys took your quiz, they're going to ask you to say, hey, like which parts of these are true and put a check mark on, that kind of stuff. So these ones are still like that. Okay. This one has a vertex at 2, 3. Okay, well, how do we find a vertex? This right here is in vertex form. Okay, vertex form is great because you can see the vertex in it. And the vertex in it is the opposite of whatever this one is. Okay, so your vertex is that. And then this number, whatever it is. This number as is. So your vertex is going to be -2, +2, the opposite of -2, which is +2, and then this number as is, which is -3. So is my vertex at 2, 3? No, so that's false. Okay, x-intercepts. Something else that you need to be aware of on your exam, that there are synonyms for x-intercepts. We also say roots. Okay, want you to find the roots of this function. We can ask you to find the solutions. Okay, we can ask you to find the zeros. I think that these are the two that they use most on the exam, but just know that they're all interchangeable. So when it asks you to find a root, it's asking you to find an x-intercept. Okay, so how do we find x-intercepts? Well, let's take it back to when we were graphing lines and doing, easier things. How do you find an x-intercept? To find an x-intercept, you make y equal to 0. Okay, so let's do that. Let's make y equal to 0. This guy right here is y. So we have 0 equals the absolute value of x minus 2 minus 3. And now this looks like a problem that you guys can do. I'm going to add 3 to both sides. 3 is equal to the absolute value of x minus 2. Absolute values by itself, set up your two equations. X minus 2 equals 3, x minus 2 equals -3. And solve. X equals 5, x equals -1. So are my x-intercepts 5, 0 and -1, 0? Remember, when you write x-intercepts, you write them as an ordered pair. So yeah, this guy right here is true. That works. Okay. And the last one, finding a y-intercept. To find a y-intercept, you make x equal to 0. That's how you find a y-intercept. You make x equal to 0. So let's look at our function. We have y equals the absolute value of 0 minus 2 minus 3. I just plugged in 0 for x right here. Okay, 0 for x. That's it. And then when I solve this, y is equal to the absolute value of -2 minus 3. Okay, y is equal to 2 minus 3. Y is equal to -1. Okay. Now, a lot of you guys, this is where you need to make sure you're really careful when you're taking math exams, especially ones where there's multiple choice. This is a good wrong answer because this says -1, 0, but that's an x-intercept. Okay, so this one right here is going to be false because the y-intercept is not at -1, 0. The y-intercept is at 0, -1. That is your y-intercept. Okay, so this one's written backwards. So be careful of stuff like that on the test. You're going to have plenty of time, and just remember that on a multiple choice test, they're going to put good wrong answers in there and distractors to make sure so that we know that you really know what's going on. Do you know that that's how you write an x-intercept? Do you know that that's how you write a y-intercept? So make sure you guys are good with that and that you're comfortable with paying attention because these little things will trip you up a little bit. Okay, continuing on. Let's get to graphing. I think this is everyone's scared part. Let's go this way. Okay. All right, I'm going to take one at a time. So let's do this one first. This is the absolute value of x minus 2 minus 4. So when we graph, we need to identify roots, which are like x-intercepts, a y-intercept, and then we need to find a vertex. So you have to do all of those things to graph your absolute value function. So let me grab a piece of paper. I'm going to write it on there. There we go. Okay. We've got x minus 2, y equals x minus 2 minus 4. Okay, so let's find the x-intercepts first. All right, to find the x-intercepts, you make y equals 0. So 0 is equal to the absolute value of x minus 2 minus 4. Now I want to solve. Add 4 to both sides. 4 is equal to the absolute value of x minus 2. Now that it's by itself, set up your two equations. X minus 2 equals 4. X minus 2 equals negative 4. Add 2 to both sides. X equals 6. Add 2 here. X equals negative 2. Okay, you found your x-intercept. So let's graph those at 6, 0 and negative 2, 0. So we are at 6, 0 and negative 2, 0. It's important that you know how to do this because on your test, if you're asked to write them in an ordered pair, you need to do it this way. Okay, otherwise the computer's going to mark it wrong. You can't just write 6 or negative 2. You're going to need to write it as an ordered pair. So careful with that. Okay, so let me graph those real quick. We've got x equals 6 right there and negative 2. We've got 2 x-intercepts. Okay, let's continue. We need a y-intercept. Okay, we need a y-intercept. And in order to find a y-intercept, we're going to make x equal 0. So we're going to get y is equal to 0 minus 2 minus 4. Y is equal to the absolute value of negative 2 minus 4. And again, now you're just kind of evaluating. Y is equal to 2 minus 4. Y is equal to negative 2. So remember, if it asks you, your y-intercept is at 0, negative 2. Okay, let's graph 0, negative 2. Right there. There's my vertex. I'm sorry, my y-intercept. My y-intercept. And then I need my vertex. And my vertex is easy to see up here in my function. Actually, I can just write it up here for vertex. My vertex is the opposite of this number, which is 2. And this number as is, negative 4. 2, negative 4. So over 2, down negative 4. There's my vertex. Connect the dots. Make sure on your test when you do this, you actually draw in. And I know on your test it's a little bit harder because you're doing it on the computer, but you can do it. Make sure you draw it in. Absolute value graphs are going to look like a V. Okay? So we found all the components for that. All right, let's try another one. Okay, I have 2, 3 more on here. Some of them are a little bit tricky. I don't know if you'll have any that's hard on the test. I think they're mostly like this, but I'm going to give you these 2 just because I think you can do it. All right, let's do this one. This is the absolute value of x plus 1 minus 2. All right, so again, you can find the vertex first because the vertex is right here. The vertex is at negative 1, negative 2. The opposite of this number and this number as is. So we have our vertex, and your vertex is an ordered pair. It's a point on your graph. Okay, so there's your vertex. Let's find your y-intercept. I'm going to switch it around this time so you guys don't get used to it. Finding your y-intercept, make x equal to 0. Make x equal 0, and then solve. So y is equal to 0 plus 1, the absolute value of that, minus 2. Y is equal to 1 minus 2. Y is equal to negative 1. So my y-intercept is at 0, negative 1. Okay? And then we have x-intercepts. If you guys have any questions, jump in here, put them in the chat. Need me to do something else, let me know. I can come back to it at the end. Like I said, I can redo some of these if you want. Just let me know what you guys need. All right, so we're here. X-intercepts. How do you find x-intercepts or roots? You are going to make y equal 0. So make y equal to 0 and then solve. So 0 is equal to the absolute value of x plus 1 minus 2. Solve your equation like you already know how to solve an absolute value equation. And we did these right here. We're at this part right here, just basic solving. Okay? Add 2 to both sides. 2 is equal to the absolute value of x plus 1. Set up your 2 equations. X plus 1 equals 2. Kill that little guy. X plus 1 equals negative 2. Subtract, x equals 1. Subtract 1, x equals negative 3. Your x-intercepts are negative 3, 0, and 1, 0. Okay, and let's graph those now. We can put them all on the graph. So our first one, our vertex is at negative 1, negative 2. Our y-intercept is at 0, negative 1. Our x-intercepts are at negative 3, 0, and 1, 0. So right there, you have your points. Make sure that you do this in a V shape again, and that your V shape goes on and on and on. Okay, it continues. All right. So these are the two like you're probably most going to see on the test, or you'll have to say, you'll look at this and they'll give you the true and false things on it. Just a whole bunch of different things we can do with matching these up, or true and false, drag and drop, those kind of things. Okay. Let's do this one. This one's, it's not hard. It's just it's a little different. So let me move that up there real quick. And I'm going to put this one right here. So this one right here is y equals the absolute value of x plus 2. All right. And so let's do this. We want a vertex, a y-intercept, and x-intercepts. Okay. Well, my vertex, I know it's the opposite of whatever is in here, which is going to be negative 2, and whatever is out here. Okay. And what's out there? What's out there is 0. So your vertex is going to be negative 2, 0. All right. My y-intercept, I can just make x equal to 0. So my y-intercept is equal to the absolute value of 2. Y is equal to 2. So my y-intercept is at 0, 2. Okay. And here's a little tricky part with your x-intercepts, or x-intercept in this case. So to find an x-intercept, I make y equal to 0, and then I set up my equation. So I have 0 is equal to the absolute value of x plus 2. Okay. Well, when I set up my two equations, I have x plus 2 equals 0. Okay. There's no such thing as negative 0. So this equation right here, that doesn't exist. Okay. We don't have a negative 0. So when it's equal to 0 like this, you're only going to get one solution. Okay, and that's going to be negative 2, x equals negative 2. My x-intercept's at negative 2, 0. Okay, and let's see what happens when we graph this. So this guy right here, when your absolute value is by itself and it's equal to 0, you get one solution, okay, or one x-intercept, one root. That's what happens for this one. So let's graph these real quick. I have a vertex at negative 2, 0. And funny enough, that's where my x-intercept is also. Yes, they can be the same. And my y-intercept is at 0, 2. So for this one, all my points kind of look alike. They're all part of the same. When you do this and you get into Algebra 2, they'll have you pick symmetry points, so that what happens on one side is kind of like, I know you guys know this from geometry. So like you have an axis of symmetry. So whatever's here is here, like rotation and things like that. You guys can make sure that they reflect properly. So that was what your graph would look like. Again, you have one root, and it happens to also be the same as the vertex. Okay. All right. And then let's try this one. This one is a little bit trickier. But again, I know you guys can see it. And I mostly put these on here not because you guys are going to have to graph them, but because you need to be able to see what's happening with these things. Okay, it's a little bit trickier. I want you guys to be able to look at these, even if you don't have to graph them, and say, oh, wait, I already know where this is going. I already know what they're asking. Okay, so let's do this. Vertex, easiest thing to find. Don't screw up the vertex. That's easy points. All right. The vertex, again, the opposite of whatever's in here, negative 1. Whatever number's out here, 3. My vertex is at negative 1, 3. Okay. So let me show you guys this. This is my vertex. It's at negative 1, 3. It's all the way up here. My V is going to come up here. So even by looking at this, I hope that you guys start to see that this is not going to have, this isn't going to cross the x-axis. But I'll show you why and what we look for mathematically. Okay, before we get into that, let's find the y-intercept. Y-intercept's easy. Make x equal to 0. Let's do that. So we have y equals the absolute value of 0 plus 1 plus 3. Y is equal to 1 plus 3. Y is equal to 4. My y-intercept is at 0, 4. Let's graph that too. That's at 0, 4. And remember, all your graphs are going to look, okay? Let's find our x-intercepts. To find your x-intercepts, you make y equals 0. So 0 is equal to the absolute value of x plus 1 plus 3. Subtract 3 to both sides. Negative 3 is equal to the absolute value of x plus 1. And this is where the light bulb should come off, okay? Right here. When you have the absolute value of something, you can't get a negative, okay? There is no number that I can put in here to make that true, okay? So when this whole thing, once the absolute value is all by itself, and there's a negative on this side, you are going to have no solutions, okay? Because I can't set this up. I can't say x plus 1 equals negative 3. If I were to solve that, let me show you guys how this works, okay? I'm going to get x equals negative 4, right? Well, let me plug that in and see if that works. All right, I'm going to plug it in. I get the absolute value of negative 4 plus 1. The absolute value of negative 3 is 3. Well, 3 doesn't equal negative 3. That doesn't work. So this is where you really need to think and say, okay, wait, my vertex is somewhere above the x-axis, and this is a positive. This is all positive, and I know my graph is going to look like that somehow. These must have no solution, okay, or no x-intercepts, right? Because this is a no solution type of problem, right? So when you were to graph this, your graph is going to look like this. It's going to be above the x-axis. And again, not so much that you're going to have to graph these, but it is important that you understand the dynamics of what happens when you have when you end up with something like this, when you have an absolute value equaling a negative, okay? It just means no x-intercepts. You're above the x-axis. All right. I know, it's a lot, okay? Last parts, all review, okay? Everything else review. This stuff, you guys should be able to do in your sleep. Unfortunately, I know some of you can't do it in your sleep, which is why we keep putting it on your tests, because you guys keep getting these things wrong, okay? So you need to determine if the system of equations has one solution, none, or infinitely many solutions, okay? And to do that, you are not going to solve every problem. You're not going to do that. That is a big waste of your time, because what you need to understand is how this works with slope. Okay, how it works with slope. You're looking for slope. All right, so if you have the same slope, okay, same slope, there is no solution. You have parallel lines. Okay, remember, solutions in your system of equations is how many times the lines intersect. So solution for this, for a system, let's see, system solutions are the number of times the lines intersect. Okay, so same slope, no solution. One solution is when you just have two different slopes. Two different slopes. Okay, so one solution is, and infinitely many solutions is when you have the same line twice. Okay, and we'll look at that. Okay, so let's look at this. Let's take A. All right, A works for the first one because it's already in slope-intercept form. All right, so I can see my slope right away. I don't need to manipulate this equation. It's right there. I can see it, and my slope for this one is negative 1/3. Okay, negative 1/3. This one I can't really tell. Okay, so this one I have to put into slope intercept. So let's do that. I'm going to subtract 4x to both sides, and I'm going to get 3y equals negative 4x plus 18. I'm going to divide everything by 3, and I get y is equal to negative 4/3 x plus 6. Okay, there's my slope. I have that as my slope right now. Okay, well, I know these lines aren't parallel. Okay, so there isn't no solution. Okay, I know that I can plug them into each other and I can get one solution. Okay, now the other way you can do this is if you don't want to look at slopes, you can take the long way and you can solve it. Okay, you can absolutely do that. But I think that looking at slopes will tell you if it's a little bit easier. So long way around, I could substitute that in for y. Okay, and I would get 4x plus 3 times negative 1/3 x minus 1 equals 18. Okay, and then I get 4x plus, if I distribute that, I get negative 1x minus 3 equals 18. Okay, combine like terms. 3x minus 3 equals 18. Add 3 to both sides. 3x is equal to 21. And then x is equal to 7. Okay, I got an x. If I got an x, I got x equals something, I know there is one solution. I'm going to plug that x back in here, and I'm going to get a y. It's not asking you what the solution is. It just wants to know if it has one or if it doesn't have one. So you could do it this way. You could just solve for one of them and see what you can do. So that way is okay too. Again, just figure out what works best for you. Like I said, I prefer to look at slopes, but if you like this, just to see like, okay, I got x equals 7. That's cool. It equals a number. I'm okay. If you get here and, you know, x, you like your variables drop out and you get 0 equals 5, well, then you know it's no solution. Okay? So let's try this one. Let's try B. Okay. Neither one of these is in y equals mx plus b form. All right, so let's put them in y equals mx plus b form. That would give me negative y equals negative 3x minus 5. So I just subtracted 3x to both sides. I can't have this negative here, so I'm going to multiply everything by a negative 1, and that's everything. And I get y equals 3x plus 5. Okay, I just took that equation and made it right there. This guy right here, I'm going to add 3x to both sides. So I get y equals 3x plus 1. Okay. I have the same slope. I know those are parallel lines. I know those are no solution. Okay. I know that. But if you don't know that, well then you have a couple of choices. You can substitute these in. I can show you why they're no solution. It's 3x plus 5 equals 3x plus 1. All I did is I'm substituting that in for y. They're equal to each other. And when I do that, I get 5 equals 1. And we know that that is not true. So this is no solutions. Okay? No solutions for one like this. All right, that's no solution. None. The lines are never going to cross. Okay? Let's try this one. Get some more paper. More paper. Okay. So depending on how you guys like to do this, again, sometimes I just like to see what we got here and put them in the same order. You can substitute them in. Let's just try substituting. If you want to do that, put it in there. I think maybe you guys like doing this stuff. We can see what the slopes are when you guys, I'll do it both ways for you. How about I do that? Okay, so I have 4y plus 12 times negative 3x. Sorry, I did that wrong. I'm plugging that in for y. Okay, so I have 4 times negative 3x plus 5 plus 12x equals 20. Okay? I just substituted. And when I distribute, I get negative 12x plus 20 plus 12x equals 20. All right? And I've got negative 12x and positive 12x. Those go away. But when I'm left, I've got 20 equals 20. And that's true. That's very different than the one we did here, where your variables dropped out and you got 5 equals 1. That doesn't make sense. But 20 does equal 20. This gives me infinite solutions. And what that means is that I can put any number I want in here for x, and it will still come out equal. It doesn't matter what I put in there. I could put in 1, I could put in 1 billion, and it doesn't matter. I could put in 0.1, and it's still going to come out because the variables will always drop out, and this will equal that. So you will not have any issues. So this guy right here has infinite solutions. Okay? And you would have seen it kind of if you guys had it this way. We can look at this guy right here. I'm going to do it again for you. We have y equals negative 3x plus 5. Okay, that one's already done. And then I have 4y plus 12x equals 20. Okay. If I put this in y equals mx plus b form to check out the slope, all right, I'm going to have, subtract my 12x, 4y equals negative 12x plus 20. And when I divide out everything by 4, I get y equals negative 3x plus 5. And you look at that and you're like, wait, it's the same thing. I have the same line twice. So on a graph, basically what you have is you have, let's see, here's 5, and you're down 3 over 1. You have a line that looks like this. There's that one. And then you have the same line. So it has every single point. All of these little points are in common. So this is infinite solutions. All right, infinite solutions for that one. This is infinite. All right. Here. Okay, looking at this one. You guys are going to have the same slope for these. I don't have to do any extra work. I have 2. This is in slope intercept form. I have 2 for my slope in point slope form. My slopes are the same. I'm going to get parallel lines. Okay. Now, where you need to be careful is if it's the same line. So we could add this one out to make sure it's not the same line. Y minus 3 equals 2x plus 2. Oh, maybe it is the same line. Add 3 to both sides. How funny, I randomly did the same thing. Y equals 2x plus 5. Ooh, I have the same line twice. Okay, so those are infinite. Same line twice. Okay. This one right here, I can already tell it's one solution. And the reason I can tell that is because I have perpendicular slopes. Okay, perpendicular slopes there. All right. And then the last one, let's do this. Let's put them in y equals mx plus b form. This one is y equals 3x minus 4. I'm just adding that over there. And then this one I'm going to manipulate. That's 2y equals negative 4x plus 8. Divide everything by 2. And I get y equals negative 2x plus 4. Okay, completely different. This is just going to be one solution. If I put it in there, I'm going to be able to solve it, and it'll be fine. Okay. There's a system on your exam tomorrow. Okay, and there's a lot of missed points on the last system, and I think it came into when you guys had to set up your equations. And you can set them up however you like. And for this one, sometimes they want you to identify your variables, or they tell you what variables to use. So if they do that, make sure you use the variables they tell you. All right, so Mr. Chong spent $131 on shirts. Fancy shirts cost $28, and plain shirts cost $15. If he bought 7 shirts total, how many of each did he buy? Okay, well, let's look at what numbers are. We've got 131, 15, 7, 28. we've got all of our numbers here. Let's look at, let's deal with how many shirts he has. He has fancy and he has plain. So I'm going to make F equal my fancy shirts and P equal my plain shirts. Okay, so my fancy, my plain. And I know that the fancy shirts plus the plain shirts equals 7. I know he bought whatever combination. He could have bought 1 fancy shirt and 6 plain shirts, or 3 and 3, or 3 and 4, or whatever. Whatever he did, the combo equals 7. Okay. I also know that a fancy shirt costs $28. So 28 times the fancy shirt plus 15 times the plain shirt equals 131. And now you can go about this whichever way you are most comfortable with. So you can multiply the top by negative 28 and eliminate. You can move one of these over and substitute. And at this point, I think a lot of you guys would be able to probably like guess and check and figure out which one works. But it's important to do the math to see which one works better for you. I think that my class in particular likes to eliminate. So I could see them wanting to, I don't know, I would say they would probably want to get rid of the F's. I don't know. So they are going to multiply the top by 28. Okay, or negative 28. So that'll give them negative 28F for that one. And then that'll give them plus or minus 28P. And that's going to equal, we have 28 times 7. Let's see what we got. We got 56, 196, negative 196. And then that'll eliminate that. All right, right here, that's going to give me negative 13P. And when I subtract that, that's going to give me 65. And when I divide both sides by negative 13, I'm going to get P equals 5. Okay. Now, with your negatives here, okay, I know there's a lot of negatives. Make sure that you're looking at this correct, okay, because you wouldn't get negative 5 shirts. This type of problem doesn't make sense if there's a negative in it. So his P equals 5. That means he ordered 5 plain shirts. If he ordered 5 plain shirts here, that means he ordered 2 fancy shirts, and he's good to go. All right. Last one. The exponential graph. Okay? Last one for the night, unless you guys have questions. Gotta go this way. All right. Complete the table and graph the exponential function. F of x equals 2 to the x plus 1 power. They're giving you your table of x's. So all you're doing is plugging these in. Okay, so let's do the first one. I have, I'm going to plug in negative 3. So I have, I'll do it right here, 2 to the negative 3 plus 1. That gives me 2 to the negative 2 power. Okay, well, I can't graph 2 to the negative 2 power, but I know with that negative exponent, I can bring it down. So I'm going to get 1 over 2 squared, okay, which is 1 over 4. So there's my y. Okay, let's do negative 2 now. I've got 2 to the negative 2 plus 1 power, which is 2 to the negative 1. I can't have that, but I know I can bring it down, which is going to give me 1/2, 1 over 2. Okay, putting in negative 1. 2 to the negative 1 plus 1 gets me 2 to the 0 power. Anything to the 0 power is just 1. So that equals 1. Let's plug in 0. 2 to the 0 plus 1 power. 2 to the first power equals 2. That guy's there. Again, just plug and chug. Plug in 1. 2 to the 1 plus 1. It's me 2 squared, which equals 4. Okay. And last one, 2 to the 2 plus 1 gets me 2 to the third. Okay, and 2 to the third, remember that is not 2 times 3, that is 2 times 2 times 2, which equals 8. All right, I'm there. Graph them. Okay, these ones are a little bit hard to graph. I'll give you that. Okay, they're a little bit difficult, but we have x equals -3, y equals 1/4, x equals -2, y equals 1/2. I know, it's kind of hard. X equals -1, y equals 1. Okay, but there's one that you can easily see. X equals 0, y equals 2. Perfect. X equals 1, y equals 4. Another easy one to see. And x equals 2, y equals 8. What's important on this is that it asks you to graph it. It doesn't ask you to just plot the points. And you need to know that exponential functions, this is an exponential function, okay? They are J curves because they look like a J. And it's going to come like this. This is going to come up like this and then continue on forever, okay? But make sure when you do these, you connect the dots. All right. This kind of stuff, you're going to get a problem like this on your test tomorrow for sure. All right. There is for sure a system of equation. There is some sort of like check off the boxes for what are like infinite, none, or one solutions. There are graphing, okay? There's graphing. And not just graphing like find all the work and graph. There's that, but there's also, hey, look at this graph and tell me what the x-intercept is or what the y-intercept is, or does this one, how many solutions does this graph have? Okay, how many solutions does this graph have? So that's an easy one. It has none. So you're gonna have to be able to look at graphs and answer questions about them as well, not just graph them. And then there will also be the standard solve, evaluate, that kind of stuff, okay? There's an extra credit question on the test tomorrow. All right, there's an extra credit question. Skip it unless you have time. If you have time, spend some time on it and see what you can do. It is very challenging, but there is an extra credit question on the test. So, you know, don't waste all your time on it. Get through the whole exam first. I think the extra credit question is actually somewhere in the middle of the exam, so make sure you read it and you're like, I have no idea what they're talking about. But it is worth a look just to see what you guys come up with. And so that is that. If you have any questions, let me know. You can type them in the chat. If not, good luck tomorrow. Your exam will open at 9 a.m. and will close at 9 p.m. So you have from 9 a.m. to 9 p.m. to take your exam, and you will get 75 minutes to take your exam tomorrow. So we increase the time for you guys. Okay? All right. And for those of you guys that checked in, I will let your teacher know that you did come to my session tonight so that they know. All right. I'll talk to you guys later unless there's anything else. Otherwise, good night and good luck tomorrow.